experiment, we have a substance called Dumbledorium, and we've got 20 milligrams of this substance. We know that the substance has a molecular mass of 550 gram per mole, and we want to know how many moles of this Dumbledorium actually did we get. So what we can do is we can use dimensional analysis and try to find out what the number of moles is. So we are looking for mole. And the question is, do we have moles anywhere? Yes, we've got moles here. So all we need to do is write it in such a way that the mole is on top of the fraction line. Mole over 550 grams. That is how we would write this. Now the moles is in the right place, but we need to get rid of the grams. So we multiply it just simply by something with grams in it. And we've got grams here. So we've got 20 milligrams. We need to be careful with the unit. So the milli indicates 20 times 10 to the minus 3 grams. What we see is that the grams cancel out. And all we have left is the unit mole. This is exactly what we want. So we can basically stop and we can write this as 20 times 10 to the minus 3 mole divided by 550, and the grams of course cancel out. And when we put this into a calculator, I make it as 3.64 times 10 to the minus 5 mole. So this would be the number of moles that we actually have in this 20 milligrams. So I hope this makes sense. Okay, then we perform an experiment with this Dumbledorium, and for that we need to prepare 2 milliliters of a 200 micromolar solution. And the question is, how much of this Dumbledorium do we need to weigh in? So let's just simply do the calculation in gram first and then convert it to milligrams. So we are looking for the number of grams, and we know that we have a molecular mass of this Dumbledorium of 550 gram per mole. So we can use this here, and we have grams here. So we've got 550 grams per mole. So the grams are already in the right position. But now we need to get rid of the mole. Do we have mole anywhere? Yes, actually it is in this molar solution, because what we have is 200, because what we know is that molar just simply means mole per liter. So we can write these 200 micromoles. We can write this as 200 times 10 to the power of negative 6. That's our micromole. And with the unit mole per liter. And what we see is that the moles cancels out. But now we've got the issue with the liter. So we have to multiply it with something with the unit liter in it. And luckily we've got something with the unit of liter, because we've got 2 milliliters. So we can write this as 2 times 10 to the power of, now we've got milli here, 10 to the minus 3 liter, and the liter cancel out, and all we have actually left is the unit gram, and that is exactly what we want. So we can put this into a calculator, and if I have pressed the keys correctly, then it should be 0.000 2 gram. Now we are asked to give the answer in milligram, and what we can do is in order to convert from gram to milligram, we just simply need to multiply everything by 1000, because there are 1000 milligram in 1 gram. So what we can do is we can just simply shift the decimal point 3 places to the right, and we would get 0.22 milligram as our solution here. So we would have to weigh in 0.22 milligram to make up this 2 milliliters of a 200 micromolar solution. In this experiment, we want to make a new solution, and we have basically a working solution here. And we use a stock solution that we have made up, and we need to figure out how much is our dilution factor. And we know that we can calculate a dilution factor. So we can calculate dilution factor by just simply dividing the working solution. That's the working solution. I should probably better do it the other way around by taking our stock solution. Let's do it this way around. Stock solution, because then we get a larger number. Stock solution divided by the concentration of the working solution. Working solution. So that would give us our dilution factor. Okay, so what have we got? We have the stock solution. That's our 200 micromolar solution. So that's, we already know, 200 times 10 to the minus 6 mole per liter. But our working solution, unfortunately, is not in the right unit. It's not in the mole per liter. It's in milligram per milliliter. So how can we convert that? So what we are looking for our working solution is the unit mole per liter. And how can we do that? Well, we know that our Dumbledorium has a molecular mass of 550 gram per mole, so we can use that. Mole over 550 grams. So we've got the mole in the right place, so that's good. And now we need to use something so that we get the grams cancel out here, and we put in the liters here. So do we have anything like that? Yes, we've got that here with our milligram per milliliter. So we can write times 0.002 times 10 to the minus 3 grams. That's our milligrams. And we have them in 1 times 10 to the minus 3 liter. That's the milli here, so that's the liter. And what we see is that the grams cancels out. That's good. And as the unit, we've got mole per liter left. So we can write the concentration of the working solution as 0.002. Now the 10 to the minus 3 even cancels out, so we don't have to worry about that. Divided by 550, and the units that we have left is mole per liter. So that's the unit, and that is the concentration of our working solution. So we can put that in here into this equation here. So divided by 0.002 over 550, and the unit is again mole per liter. And when we basically do this calculation, we get a value for this of roughly around 55. So our dilution factor would be 55. We have to dilute our stock solution 50 times to get this working solution with this particular concentration. If you want, we can calculate that. So if we put that into a calculator, this would be a working solution of 3.64 times 10 to the minus 6 mole per liter. Might be useful to do this calculation for further calculations down the line. Have to dilute our original stock solution 55 times to get this working solution, and we want to have exactly 7.5 milliliter of this working solution. So that's here is our working solution. And how can we actually calculate how much volume we want to use? Well, that's quite simple. The volume that we are looking for, volume of the stock solution, that is just simply the total volume that we want to have. That's the total volume, 7.5 milliliter, and we want to dilute that 55 times. So we just simply divide it by this dilution factor that we've calculated. So that gives us 7.5 milliliter divided by 55. And if I've done that correctly, that should give us 0.136 milliliter of the volume of the stock solution. And this basically is an application of the equation C1V1 equals C2V2. We are looking here for the V1. So V1 equals C2 over C1 times, I forgot the 2 here, times V2. And this here is actually our dilution factor. So if you wonder how I come up with this equation here. So that's the dilution factor, or rather the inverse of the dilution factor, because I used it the other way around. But that is pretty much the same thing. So we need to use 0.136 milliliter of the stock solution. And now we also need to figure out how much of additional dilutant do we need to make up these 7.5 milliliter, and that is actually what the next question asks us. So we need to calculate here 7.5 milliliter minus 0.136 milliliter, and that gives us 7.364 milliliter. That is the solution of water or buffer here, because if we put this solution, the buffer solution, plus our stock solution, then we get the 7.5 milliliter that we wanted in the first place. So I hope this makes sense and gives you an idea how we can actually do these calculations when we are working with dilutions and molarities.